Right. So very quickly, let's try to do some mind mapping. Remember, I mentioned about mind mapping, about doing your notes and how you can actually try to do this yourself. And then you are going to be very good at this. And it's going to help you study better also. If you can see my screen, give me okay, it's a blank screen, just in case you're wondering. What are you supposed to be looking at? It's a blank screen.
What is it for?
It is for us to start doing our mind mapping. Okay, so today we are going to try something together, right? Because it's time you really picked up, mind mapping skills. Do I want this color pen? Maybe it won't be so nice, right? I can't decide, you see. Terrible. Okay, then I just take blue. Right, so what is this topic on?
Miss Day, our school, my teacher already made me do one.
Very good. Okay, so you can give ideas.
In art class, I made a mind map about Vincent van Gogh, so I know how they're made.
Yeah, so y'all know, right? But I'm surprised that there are still many students who don't know. How many of you don't know mind mapping? Can you raise your hand, please? Sam don't know, huh? How about Hanin? Hanin, have you done already mind mapping? Caleb also not.
I did.
Okay, now you have to see Teja's mind map is like that. Your mind map will be different. Mine will be different. You want to look at mine? Mine will be very messy.
What is mind mapping?
It's mind mapping. Mind mapping starts like this. So your focus, we might be doing mind mapping from now on for every lesson. Okay? So what you do is you start with a very general idea, okay, right in the center of the paper. Mine is, of course, the PowerPoint slide. So we are doing the topic on water, okay? And I spelled water wrongly. Okay, now, so we are going to write down the topic, which is water, okay? But then you know that this involves what? Changes of states, right? Okay, so for me, because I have learned in higher level changes is actually represented by a triangle. So this is what I do, but you might do it differently, correct? Okay, so you have your own short form, use your own short form because mind map is only meaningful to you. Or shall I say, your own mind map will be meaningful to you. Is that clear? Okay, you are in P5, so I want to start instilling this in you because mind map will be very powerful for you to summarize one entire lesson. You don't need pages and pages of notes. When I was young, I like to write down water at the top, point form, then another point form, another point form, and so on. And I realized that didn't help me at all. I become very rigid in my thoughts also. So your thinking process can actually be influenced by how you do your notes. Okay, so let's talk about this changes of state thing. Yeah, so we can maybe just do this. If you look at what I am doing, you might do it differently. Okay, so there are 3 states, right? Solid, liquid, as well as gas. So this is a very general term, 3 states of matter. If you are able to tell me solid state of water, that will be even better, right? Tell yourself also, you can even, put in bracket form or you change color. Usually I encourage my students to actually use marker. So they go and buy this thing they call what? What's that called? I think it's very cheap only. What's that called? Very colorful, many pens. For drawing, they go to Daiso and buy it. Okay, can't recall suddenly, but they went to Daiso, $2, one whole pack, many colors. So they can write things like this. Okay, then this is liquid water. And then in gaseous state, what do you call water in gaseous state? Giselle?
Water vapor.
Water vapor. Hanin?
Water vapor.
Water vapor. There's also another one, other than calling it water vapor,
Water droplets.
Not exactly. When it is water droplets, it's actually liquid.
Oxygen, air, oxygen, carbon
Is it
dioxide.
Steam, very good. Somebody got it. Okay, now, what is the difference between water vapor and steam? There's a big, big difference, right? And then I'm going to go in more detail later. So you can have something like that. Of course, my mind map is very different from yours, right? Yes or no? Okay, so now we identified the 3 general states of water. Then you can also start now writing about something else. Okay. You might want to talk about the changes of the states already, right? So if you want to branch out, I think it'll be nicer if I branch out. So let me do something different here. Okay, I might want to go to the bottom. So if you see a very nice mind map will have branches. Okay, I can do it this way, right? So here, maybe I want to, okay, I can move my writing pad so I can write this way. See whether it works, okay? Not so good at this. Let me have some time to practice because I don't usually use the screen or the PowerPoint to do my mind map. I write properly also becomes so small. Can you all see what I'm writing?
No.
Yeah, okay, I try again. Or maybe I don't do it that way lah. I just do it the normal way.
Are you writing on computer or what?
Writing, right?
This day, are you writing changes?
Yeah, I'm actually using this. Okay, I have this writing pad. All right, connected. There's a cable connected to my laptop. Yeah. Okay, because this laptop of mine doesn't have the touch screen. Okay, so let me just write smaller here. Okay. So what am I doing now? So I'm identifying what? Changes of changes of states. What's that?
It's okay.
Oh, okay. Yeah, sure. So now I'm going to do a bit of short form. Okay, when solid, okay, changes to liquid. Call this
Melting.
melting. Very good. So melting. Maybe use another color, yeah? Let's try orange. Hopefully the whole thing will turn out nice. So we have melting.
Melting.
Okay. At what temperature does it take place?
0 degrees.
Zero.
That is for, okay, Caleb, you put out your hand. I want Caleb to try to participate as well. Caleb, come.
0 degrees.
0 degrees. And that is what to what?
0 to 5.
Yeah, solid to liquid, but what? Remember, very specific example. You said 0 degrees is referring to ice changing to
Liquid.
liquid water. Okay? Ice changing to liquid water. So now we identify a 0 degrees Celsius. We call this the melting point. It is the temperature at which, okay, it is the temperature at which ice turns to liquid water. Okay? Sometimes you can draw. People who can draw very well, I will want you to draw. I cannot. Okay, you know, you have seen my drawing, right? So you wouldn't want me to draw, right? Yeah, I know. That's okay. Okay, I'm going to teach you something extra later on. Don't be shocked when you see, okay? Now, there's another state after the ice change to liquid water. If I carry on heating and heating and heating, what will happen to the liquid water?
Liquid water
Developed into water.
becomes gas.
Becomes gas. Some say water vapor. Some say becomes gas.
It will start
What else?
to boil.
You will start to?
Boil.
You will start to boil, correct? And it will change to?
Boil.
to gas. Somebody said that already. Some people say steam, right? Some people say water vapor, right? Yeah, not entirely wrong, of course. You change another color. So now I call this boiling. But I want you all to take note of one more thing. Boiling takes place at the boiling point. For water, what temperature will this be? Teja?
100 Celsius.
100 degrees Celsius. Good.
Oh,
This day,
Okay. Yes.
you know, when the water starts to boil, there will be some bubbles going to the bottom of the water.
Uh-huh.
Because boiling goes through the whole water, but then only evaporation occurs on the surface of water.
Yeah, you see, boiling takes place throughout the liquid. Okay. Then we are going to talk about evaporation. Yeah. So when liquid changes to gas, over here, this is known as boiling, right? Then we have boiling point at 100 degrees. So what happens here? You need to write down very specifically because this will help you in your revision. So now water turns to
Water
steam.
vapor.
Steam is actually the water vapor at 100 degrees Celsius. I told you I want to tell you the difference, right? So steam is actually water vapor at 100 degrees Celsius. Why am I saying that? You will understand it in a minute's time. Or maybe less than a minute. Okay, I'm going to erase this first because I need a little bit more space, okay, for this branch. So I'm going to use another color. Why? Because it's going to help me to remember this better. Come, choose color. What shall I use?
Red.
purple. Purple is
Purple.
Purple already used. Maybe green?
Maybe green? Yeah, I think try to choose something that is more different, right? It looks a bit more different. Now, take a look. This liquid becoming gas has another change happening. It's not just boiling, you know. Yes, honey.
Evaporation.
Yes, very good. Evaporation. Okay. And then this is also liquid becoming gas, right? Oh, somebody is here. Let me just let the child enter. Okay, back here. So liquid to gas as well. So I need more space. You see, whenever I do on screen, I don't have enough space to write everything I want to. Okay, this is where water turns to
Gas. Steam.
water
Vapor.
vapor. Okay, you know, evaporation can take place at room temperature also, right?
Yeah.
That's why I pour, let's say I don't pour pour doesn't sound good. I accidentally spill water on the classroom floor. Is that a big deal?
It will evaporate.
Yeah, it's not a big deal because Singapore so hot, right? It will evaporate very soon. Okay. Now, so this is the difference. Honey, yes, honey.
Seems like evaporation can happen at any time. Can evaporation happen at solid state?
It can happen. Okay. Let me tell you.
Any temperature.
Yeah, let me tell you why. If you go higher level, you are going to study these as well. You will have a lot of conversation with your lecturers and so on. You know, when I was a student, I asked a lot of questions. Okay. Only when I'm at higher level, at university level. Okay. So a lot of teachers will not discuss with you about evaporation in the solid state at all. Right? Okay. Many will not. Okay. But actually, okay, the professor will discuss certain things, all right, with us. Okay. And then he also discussed a lot of things such as like, how come the ice cubes, do you realize ice cubes in the freezer become smaller and smaller if you don't use them?
Yeah.
Have you ever wondered why?
Because it evaporated.
Something like that, but it's not exactly that kind of liquid evaporating to solid, to a gas.